Differential Equations Section 3 Numerical Solutions. Video 7 Runge-Kutta recording the solution. In the previous video we started an example of a Runge-Kutta order 4 question. In this video we're going to look at how to write down our solution. We don't submit anything electronically for further Pure with technology, so everything that we do in the computer we need to be able to record on our exam paper in order to get the credit for it. So here was the question we were looking at. We were finding solutions to dy by dx equals x plus y over y squared using Runge-Kutta order 4, and we were looking at a step size of 0.2. So we need to state the formulae that we've used. So we would write down everything that we did in the spreadsheet. So first of all, we put 0 into cell A2, and then into cell B2 we put 1. Now we did our 4 k values. So C2 was equal to h times f of A2 and B2. And then D2, this was my K2 value. This was h times f of A2 plus h over 2 and B2 plus C2 over 2. My E2, my K3 value, h times f of A2 plus h over 2 again, and B2 plus D2 over 2. And then finally my K4 value, so in cell F2 I put h times f of A2 plus h and B2 plus B2. Now once I did all of that, I then did my values in A3 and B3. So A3 was just A2 plus h, and B3 was just B2 plus, and then I had C2 plus twice times D2 plus 2 times E2 plus F2, all divided by 6. And then I filled all of these down in order to generate the rest of my values. Now we looked at the step size h equals 0.2 first of all, and of course I need to specify what f was, so f of x and y is equal to x plus y over y squared. And with this step size, when x was equal to 1, I got the approximation y equals 1.9048275. Now the next part of the question asks me to find approximations with step sizes 0.1 and 0.05. So all I need to do is edit my value of h from 0.2 to 0.1, and then fill down, get x equals 1. And so my y value now is 1.90482894. And finally, for my value h equals 0.05, I can fill down in my spreadsheet again. and this time I get 1.9048290. So let's just record those. So for h equals 0.1, I got the value y equals 1.9048294, and for h equals 0.05, I got y equals 1.9048290. Now, we looked at this example before. This was the example that we used the modified Euler method on. And even going down to a step size of 0.05 on that, we were only getting agreement to 3 decimal places or so. Whereas here, we're into the 6th decimal place before we're getting a change. So you can see that this method is converging on the correct solution very, very quickly. And this is the balance that we do when looking at the Runge-Kutta order 4 method. It's that sweet spot where we've got enough k values to get to the solution quite quickly, but not too many that it's going to take a ridiculously long amount of time to enter into our spreadsheet. You might be asked sometimes to use other weighted averages in order to optimize accuracy or efficiency. So here is another example of a Runge-Kutta method. So instead of having our 4 k values that we had just now, we've got 2 k values which are specified as h times f of xn and yn, and h times f of xn plus 2/3 of h, and yn plus 2/3 of k1, and then the weighting is done as yn plus 1/4 k1 plus 3k2. So you might be asked to use a variation of the method, and you'll need to then work out how to set up your spreadsheet in order to do that. In this video, you've learned how to write up a solution using the Runge-Kutta method.